Okay, well, I managed to kick apart the cord that connects the mic, so fortunately I happened to notice it. And we need to pick up again with B here. Okay, so part B says find the time when the ship is closest to the port. Okay, well, that's going to happen where the port and the vector from P to R is going to be perpendicular to the vector from A to R. And we know that that's going to happen when their dot product is 0. So we want the dot product of vector AR dotted with vector PR has to be 0. And the nice thing is you only need to worry about the direction vector. So we already know the direction vector for AR, so we can just use 3, 4 there. And we don't have the direction vector for P to R, but we can find its vector equation pretty easily. And the reason we can do that is because we just need to do the terminal point minus the initial point. And we can get the coordinates of the terminal point because R is on the equation, or R is on the line that passes through AR. And we have that vector equation that we found earlier here. I wrote it in parametric form. I can't remember if I did that before this sound went down or not. But anyway, so because R is on the vector AR, then these parametric equations that I just circled would give us the coordinates of R for some point T. So we can use these two to find them, to get this vector PR. Let's just go ahead and do it. So the x coordinate's going to be final minus initial, so it's going to be -8 plus 6t, since that will tell us the coordinates of R, minus the initial, which is 10. And then 3 plus 8t minus the initial, which is 2. Oh, sorry, a little short on breath. Okay, now we're going to dot these together. So 3 is going to get multiplied to this whole part here. Oh, by the way, I think I'm going to simplify that first a little bit. -8, that's -18 plus 6t, and then 1 plus 8t. Now I'll dot them together. So that's going to be -3 times -18 is -54. 3 times 6 is 18t. And then 4 times 1 plus 4 times 8t. Then I cleared out some space on the top there where we can continue. We've got -54 and +4. We've got 18t plus 32t, which is 3, 4, 50t. And oh yes, and this is very nice because then we'll see that you can get t equals 1. And the units for that are hours. Okay. Example 12 is next. We only have 2 more examples, one in chapter 12 and one in chapter F. Okay. Example 12 says, consider the point P -1, 2, 3, and the line with parametric equation x equals 1 plus 2t, y equals -4 plus 3t, and z is 3 plus t. They ask us to do two things. Letter A, we need to find the coordinates of the foot of the perpendicular from P to the line. Okay, the foot lies on the line. Actually, it lies on both lines. Okay. Okay, so the first thing, well, again, we start with these the same way we always do them. We need to find the, sorry guys, my brain's a little slow. The dot product, where the two vectors, the dot product of the two vectors will be 0. So, and we have, I have to think about, I'm kind of looking at this, my notes here. That's interesting. Okay, I see what I did. All right, so we have the line right here, and we know, again, when we do the dot product, we only need to know the parametric, or the direction vector. If we have the equation of the vector, we just need the direction vector. So we have that, it's 2, 3, 1. So that's one of our vectors done, 2, 3, 1. And we need to dot that with the other one. And I have to draw a picture. So we've got this line. I realize it's in 3 space, but you don't even really need to draw it in 3 space. So this line has direction vector 2, 3, 1. And there's this point that's not on the line, P. And it's -1, 2, 3. And we're trying to find, and just ignore the fact it's not in 3 dimensions, it's still going to work. We want the foot R. So this is so much more helpful when I draw a picture. Okay, we've already got the 2, 3, 1. That's the direction vector of the line. And then, just like on that other problem, we need to get the vector for P to R. Well, again, we can do the same thing. We have the formula for R up here in our parametrics, and we're going to do final minus initial, because we have the initial point. So, cool. It's just like our last one. So it's going to be 1 plus 2t minus the initial, which is minus -1, so plus 1. And then we've got -4 plus 3t minus 2, and then we've got 3 plus t minus 3. And if you want, you can pause and you can do all this math on your own and see if you end up with the right answer. Okay, so I'll just keep doing it. We've got 0 equals, I'm going to bring the 2, 3, 1 down. Dot with, let's simplify this a little. 2 plus 2t. -6 plus 3t. Oh, and just t, that makes it a little easier. Now we can do the dot product. 2 times that first one's going to be 4 plus 4t, plus 3 times the next one will be -18 plus 9t, plus 1 times the last one is just t. I don't need the vector thingy anymore, ignore that. Now combining like terms, let's see, I've got -14, 4, 13, 4, oh, 14t. They always make it so nice for us, don't they? So again, t is going to equal 1. And we have units. Oh, we're not done. It says find the coordinates of the foot. So we just found t. The foot is the r. And that was, that we will get from the, oh no, that's not right. Ignore that I just circled. That we're going to get by plugging into the original parametrics, because r is on that line, and if you plug in t equals 1, you'll be able to find them. So when t is 1, x, y, z will be 1 times 2. So 3, the x will be 3. 1, that'll be -1. 1 in for t, and that'll be 4. So now we have found the coordinates of the foot. Yay! That wasn't too bad. Now letter B says find the shortest distance from the point to the line. So what I'm going to do is I'm going to erase a little bit. Now you know that's the points of R. R is 3, -1, 4. You know what? The easiest way really to do this, because you already know those coordinates, is just to simply, I mean, yeah, you could find the vector and find the magnitude. That's actually not that hard to do. Or you can just find the distance. That really, they're basically exactly the same thing. So let's erase a little bit now. I'll do it the vector way since we're learning about vectors. So the vector way is to find vector PR, which we get from doing terminal minus initial. So 3 minus -1, -1 minus 2, and 4 minus 3. And then find the magnitude. And the magnitude is simply the square root. You're going to square each of these and sum them. So 16 plus 9 plus 1, 10, 26, root 26. And that does not simplify. And whatever the units are, who knows. There, great. So that's letter B. And now we're on section 13F, which is on intersecting lines, is the topic. And they just have one example, and in fact, this lesson just starts right in on that example. So example 13. Line 1 has vector equation and then line 2 S and T are scalars. Use vector methods to find where the two lines meet. So where, that'll be a point. I'll put that, the point where the two lines intersect. I'm going to sound even fancier than they did. Well, the two lines meet where they are equal to each other, right? So let's just, this is basically going to be an algebra problem. Let's make the two lines equal to each other. And, well, okay. I'm going to think about how I want to write it. I guess I'll just write it out the long way. So we're going to do it where this line is equal to this line. And then you can just break it down. You can see you're going to have a couple of equations here because you're going to have the one and deals with the horizontal components. So -2 plus 3s equals 15 minus 4t. So that one I just used the horizontal, and then the vertical would be 1 plus 2s equals 5 plus t. We have two equations, we have two unknowns, we can do this. I'm going to move things around a little bit. I think I'm going to use, I like elimination, so I think I'll use that technique. I'm going to move, how about move my s's and t's to one side? So I'm going to have 3s plus 4t, and then I'm going to move my 2 over to the other side. Okay, and then I'm going to have 2s minus t, and move my 1 over, and have that. And then I'm going to eliminate by multiplying the bottom one by 4. So I'm going to have 3s plus 4t equals 17, and then I'm going to have 8s minus 4t equals 16. That's going to cancel. 11s equals 33. S is 3. Good. It's always comforting to get an integer. Then we can plug that back in. This one's here is pretty easy. 2 times 3 minus t equals 4, so that's 6. I'm going to be subtracting 6, so I'm going to get that, and I'm going to divide, I'm going to get 2. So I solve for my two variables, and it says find the point where they intersect. So we need to plug that back in. And you know what we can do? We can plug it into both of these and check and make sure we get the same result with each one of them. So I'm going to plug in 3 to this top one here. That's going to be a 3. So if I do that, x will equal -2 plus 9, which is 7. And then y will equal 1 plus 6, which is also 7. So I get the point 0.77 if I use s. Just to check, let's also use t on the bottom one and make sure we get the same result. So x will equal 15, t is 2 on that one. So 2 times -8 is, it's -8 anyway. And then y, oh, by the way, that is 7. And then y is 5 plus 2, which is also 7. So we're getting 7, 7 again, which is very comforting. And that's all they wanted from that one. So the homework will be the odds on both of these sections. See you later.